Yeah, in the memory management, as it says, the operating system performs it servicing or like service in several different sectors in the computer. So memory management is one of the major things. So far we have talked about process management and user interface providing part, right? And other kind of management which is done by the operating system. So memory management is one another important management that is done by the operating system. So due to the memory management, it basically talking about how to handle the primary memory. That means the RAM, random access memory, which is the main memory in our computer, right? So, like when we execute in a particular program, that program is inside the hard disk and it should be loaded into the operating system, right? So what should happen is there, like when we are talking about the process management, we discuss about this fact. When we execute a program, there will be processors created by that particular program, and those processors will be the things which is being loaded into the memory, right? So using the 7-state diagram and all these things, we talk about it, right? So now what is going on is now the program is in execution, processors are being created, and those processors will be taken to the main memory, right? Now it is talking about how this main memory is going to be managed with the help of operating system, right? So in the first point, I have told you memory management is the functionality of an operating system which handles or manages primary memory and move processors back and forth between main memory and disk during the execution, right? So that is need to be happen, right? Main memory ekata genalla hard disk ekata geniyana process එක කරගන්න ඕනේ, right? අපි 7-state diagram එක කතා කරනකොට කතා කරා, right? Since there are like newcomers are here, let me explain a very little of it, right? When we take our computer system, the RAM is there, and this is the place where every program is going to be loaded when it is in the execution, and our hard disk is there. Right, so this is the hard disk, right? So when the programs on this hard disk, this is a program, once it is in execution, it will create different kinds of processors from that, right? So let's say this creates 3 processors, right? So these things will be loaded into the RAM by the operating system, right? Right, so this is called the process. This is called the program, right? So when program is executed, අපි double click කරලා යාව execute කරාම ක්‍රියාත්මක කරාම, so the processors will be created. So those processors will be moved to the RAM to do the execution with the help of the CPU, right? Later, RAM will send these processors one by one to the CPU, right? So for that, it uses different kinds of mechanisms, right? But this particular thing should be managed, right? So when the operating system managing the memory, it needs to determine what amount of memory that it is going to vacant for different kinds of processors, right? So computer is a place where it generates processors frequently, right? So whenever a process being created, that should be taken into the memory or the RAM, then that particular RAM space should allocate to those particular processors, right? Otherwise, our program will not have the chance to get executed, right? So how much of memory is going to be given, like for which amount of period, or like which amount of time that they are going to have this space belongs to them, or what happened when the process execution is done, how the memory should be cleaned, right? Those kind of things are done with the help of operating system, right? Which we call the memory management. As well as there is a very important thing in here in the memory management, which we call a concept as a mapping, right? So in the latter part of your lesson, we are going to talk about this mapping, as well as with mapping, there will be some more terms like paging, right? So we are going to talk about it, right? So that explains how a particular process going to be inserted into the RAM. Again, the journey from here to here, how this journey is going to happen. So this is just an outer picture, like what we can see outside, right? So we are going to discuss what really happens here, right? So here, when a process is created, does it just go and reside in the RAM, or is there a proper order of doing these things, right? We are going to discuss about it, right? So that is what we call memory management in short, right? So these are the things the operating system is doing while the memory management is done. So the memory management keep tracks of each and every memory location, regardless of either it is allocated to some process or it is free, right? So that means operating system always looks into the RAM එක දිහා බලාගෙන ඉන්නේ, right? So it always tracks how many memory slots are there, which is being allocated for processors, and how many memory slots are there, which is not, right? And again, as I told you before, it defines, so it decides, operating system decide how much of memory is going to be given to a particular process, right? Because there will be some processors which we do not need to load the entire thing onto the RAM, right? Maybe the most wanted part, or like most important portion, will be loaded onto the RAM. Then the rest of the processors will be reside in the hard disk, right? So in those cases, operating system need to decide like which kind of a process or which part of the process needs to be taken to the RAM, right? Because RAM is again, it has a limited space, right? So that space need to be managed very well. Otherwise, you won't be able to run the programs concurrently, right? So if you take something like a video game or like a computer game, which is using very high-end graphics and all these things, right? It may be that program fully will be bigger than your RAM, right? But still, your computer is allowing you to play the game. So how it is allowing you to play the game is like for a specific moment, RAM is going to have what is essential to play that game, right? So it will be taken into the RAM, and the rest of the things will be kept inside the hard disk in a special area called virtual memory, right? So this is happening in a very speedy manner, right? A very fast manner. So we won't be experience this data will be shifted in between memory and the hard disk. We only experience the computer is good to go with the game, right? But inside it, it is a very big and very speedy scenario happening at the background, right? So if you think about, if you take your attention to the second, third, and fourth points, it checks how much memory is to be allocated to the process. Like I said, it decides which process will get memory at what time. It tracks whenever some memory gets freed or unallocated, and correspondingly it updates the status, right? So in the last point, it describes an operating system does the following activities for memory management. keep tracks of the primary memory, that is what part of it are in use by whom, what part are not in use. In multiprogramming, the operating system decide which process will get memory, when and how much. And the last part, allocate the memory when a process requests it to do so, and deallocate the memory when a process no longer needs it or has been terminated. All right. So as a summary, allocating the memory, deallocating the memory is done with the help of operating system's memory management thing. Right. So now we are going to learn about how operating system is going to do this. Right. So those are the tasks and how he is going to do it. And when operating system is going to perform this memory management unit, which is a hardware, which you can see on your circuit board, right? Rather the motherboard, right? Which we call memory management unit, which is helping to do the memory management for the operating system, right? And it has a specific task, right? In the first point, it says hardware device that maps virtual to physical address. Now you will soon get to know what are these virtual and physical addresses, right? I'm going to draw you a diagram. So you all need to copy that as well. It will be little descriptive diagram, right? So memory management unit, in short from MMU, the major task of it is like mapping the virtual address into the physical address, right? So mapping the virtual address into the physical address, it is done majorly by the memory management unit. Now this is a calculation related thing. So we should know how the virtual address is being populated, or in which part the virtual address is going to have, and in which part the physical address is going to have, right? So now in the third point, it describes about the logical address and the physical address. So see, an address generated by the CPU, it is called the logical address, and physical address, it is says address seen by the memory unit, that is one loaded into the memory address registry on the memory. So in simple terms, now we use logical as well as the virtual word, which is something not physically existed, to represent which is something not physically existed, right? So logical address means it is an address, but it is not indicating a physically existing component in the system. And physical address, in the other hand, it is specifically saying what is the physical location of the computer, that means on a hardware, right? So this logical to physical address mapping is critical when we are loading a particular process onto the memory. The reason is operating system, even though operating system manage the memory, he cannot take all the processors and put it in the memory as its will, right? එයාට ඕන විදිහට දාලා ඉවර කරන්න බෑ, right? There is a particular scenario, particular workload or a particular steps to take that particular process into the physical memory, that means the RAM, right? So in that journey, right, MMU use a certain mechanism. And people, I want you to, I couldn't actually cut that down when I am printing the tute to you. So I want you to disregard this part, people. This is a little bit jumble in the explanation. So please disregard it, right? Instead of that, we are going to draw a particular diagram to show what actually happens. So that will illustrate you what really happens in the computer when memory management is done, right? So please disregard this, right? And again, with this point as well, there is no point of having something like this. So please disregard this. Answer the king. Couple of them come up now. Don't refer this part, right? Okay, people, just give me a second. Okay, so please disregard this, right? As I told you, I'm going to clear the drawing. Right. So here we are going to talk about the physical memory and the virtual memory. So another name for the virtual memory is a logical memory. So remember, virtual and logical means the same memory that we are talking about, right? So physical memory, as I told you, the RAM, the random access memory, the hardware that we can see as the main memory. So as you can see, the memory chips are there on the RAM in these black colored icons, right? So those are the places, those are the chips, those are the integrated circuits which store the data inside it when a particular process is being, or a particular program is in execution, right? So that is called the physical memory. So it is easy for us to remember. It is physical, but we can touch and feel, right? And when it comes to the virtual memory, now it is going to act a very vital role when it takes things from the hard disk and put those processors inside the RAM, right? So virtual memory is involving in both RAM and the hard disk. Why it is involving with the RAM and the hard disk? Because the program is there installed in the hard disk. So first of all, the hard disk need to give the particular processors which is populated from it. And then we have to put it, not actually we, the operating system have to put it into the physical memory. But as I told you, it won't be happening only as the will of operating system, but with the help of MMU, memory management unit, and with the help of virtual memory, right? Why this kind of a scenario need? It is because RAM is not a place which is like staying always free on the in the computer system. It deals with many different processes, right? And those many different processors are located on the RAM in its different kinds of places, right? ඒක හරියට ලොකු ගම්මානක තියෙන ගෙවල් වලට වැඩ කරන්න අවශ්‍ය පිරිස දාලා ඉන්නවා හා සමානයි. right? එතකොට අපේ village එක, if we think the village as the RAM, all the houses, right? We can consider them as the addresses or the places where the processes are to be executed or to be stayed, right? So when the operating system is trying to put a new process into the RAM, it needs to understand which memory slot is free on the physical RAM, on the physical memory. And again, operating system has no direct access to the physical memory to manage it, right? Just a second. Disturbance. Right. Sorry for that. Okay. So now I'm going to explain what is going on here from this particular diagram. So this you can see some the size of a page is equals to size of a page frame. There kind of a things are there. So I'm going to introduce you what we name as pages, what we name as frames, and how this virtual memory and the RAM is going to deal with everyone, right? Okay, so before I draw, I want you to tell you something. It's better you draw this particular diagram on a A4 sheet or a half sheet, and please paste it somewhere in between the 27th page or the 28th page, because it's described what really happens. Like මෙතන මේ තියෙන paging, mapping, and this virtual memory concepts all will be explained through that diagram, right? So you can read it through, these things, right? And it's better you go through the diagram that I'm going to draw, right? Okay, so let's start. So this is what is happening when the mapping and this virtual memory and the main memory management is done by the operating system, right? So hear this out. This will be a very crucial point to understand how the memory management happens. Okay, let me clear this first. All right. Now this is what is going to happen. Hold on a minute, people.
So exam එකට memory management process එහෙම අහනවද වෙනම ලියන්න?
නෑ. එන්නේ නිර්මාණ ඕකට අදාළව තියෙන ගණන් ටික හදන්න. දැන් ගණන් ටික හදන්න ඕන ටික තමයි මුලින්ම ඩයග්‍රෑම් එකෙන් වෙන එක විස්තර කරලා ඊට පස්සේ අපි ගණන් ටික හදන පැත්තට යනවා. right? memory management process එකේදී ඒගොල්ලෝ අහන්නේ මේ දැන් මේ අපි හදන අපි කතා බහ කරන එකට අදාළව ගාන කොහොමද කැල්කියුලේට් වෙන්නේ කියන එක තමයි. right? Hold on, I need to keep the reference regarding this paper. Second. Okay, keep this as the reference because I may need those things for some things over here. Right, here we go. Right, now as I told you, our programs are inside here in the hard disk, right? Right, so this is the hard disk. And programs will be on this as it is. Right, so once this is in execution, let's assume it's going to create some processes, right? Like P1, P2, and P3, right? So these are called what? These are called processes. Right, so when a program is in execution, the processors will be created, right? So each and every process will be mapped into a logical memory, right? Each and every process will be mapped with the logical memory. So logical memory is going to be something like this, right? I'm going to illustrate the logical memory. As this. And let me refer the capacities over here. I took it as 16 byte. Yeah, 16 byte. So this particular process is big as 16 bytes. Right. Right now, I'm talking about one particular 16 byte process, right? So this process will be loaded into the logical memory. And logical memory has a component called pages. Yeah, it's better I draw this a little bit lower, otherwise I won't be able to show you the things. Right, this is what we call the logical memory. And this logical memory has a component called pages. Now that particular page has a fixed size onto it, right? So this component is called page. and it is big as 4 byte. Now here I'm taking an example, people. This doesn't mean that all the computers all the operating systems are having logical memory as big as 4 byte, right? So page size is 4 byte. That means inside this page, it has a room to complete or to store 4 bytes, right? So that is why I'm dividing this into 4 separate places which are identical for each other, right? So this small piece is 1 byte size. Right? So this is regarding what? This is regarding this process. Right? So this particular P3 process will be inserted into this particular logical memory. Right? So then, now when the operating system needs to access a particular byte of a process, it's going to give an address to each and every byte regarding the identifying purpose, right? So in the operating system, when a particular process is created, for that particular process, there will be a particular size. In that size, inside it, each and every byte, process එකේ size එක ඉන්න byte ප්‍රමාණය දැන් මේ උදාහරණයට අදාළව ගත්තොත් it's 16 bytes. So that means 16 different bytes are there. Each and every byte contains their own logical address when it is being mapped into the logical memory, and those bytes are adjacent to each other, right? එක ළඟ තියෙන්නේ, and again they have a particular pattern as well, right? So let me refer the picture. Yeah, I have taken like 0 kinds of things in there. So let me take it. So before I go for the what we call the byte things, I need to identify the pages as well, people. So, like this has 4 pages as I drawn earlier. So let me mark them as page 1, page 2, page 3, and page 4. Right, pages are starting from the 0. Page 0. This is page 1. This is page 2. And this is page 3. Right? So likewise, there are 4 pages in the logical memory. So these 4 pages are filled with 16 bytes. Now you can see there are like 16 small squares. The 1 byte කියලා ලියලා තියෙනවා වගේ bytes 16ක් දැන් මේ logical memory එක ඇතුලේ තියෙනවා. So each and every byte, as I told you, each and every byte will have their own address, right? If I start it from here, I'm going to put the address like this, like a certain tag over here. These are going to be the addresses. Right? And this address is a binary number, right? What do you mean by the binary number? So that is a number which is consist of ones and zeros, right? Then since this has 16 squares, we should have 16 different numbers, which is going to represent by a binary number, right? So to represent 16 different numbers in binary, we need 4 bits to do that. Then අලුත් අයට මේක ටිකක් alien වෙන්න පුළුවන් number system lesson එක ගැන ලොකුවට දන්නේ නැති නිසා, so I'll help you when we are writing a binary number, right? Binary number කියලා කියන්නේ දෙකේ පාදයේ සංඛ්‍යාවක්. We consider these place values, right? So මේ place values ටික පාවිච්චි කරලා we can create any kind of binary number which is from 0 to 15. බිඳුවේ ඉඳලා 15 වෙනකම් කැමැති pattern එකක් අපිට හදන්න පුළුවන්. Right? So if you want to represent 0, we are going to represent 0 like this. All 4 is 0. This is equals to 0 in base 10. If you want to represent 1, this is going to represent 1. So this is 1 in 10 base. This is in binary, right? If you want to represent 4, this is 4. Right? If you want to represent 8, this is 8. Right? So likewise, these 4 bits, using 4 bits, we are going to address these 16 cells. Right? අපිට මේකේ addresses ගන්න පුළුවන්. අඩු මේක බිඳුව, වැඩි මේක අපිට 15 කියලා අරගන්න පුළුවන්. Right? ළමයි විනාඩියක්. Right. So yeah, now we got to address these bytes one by one, like it has to be unique from each other. So we are going to give 16 different address from by using 0 to 15, right? Because using 4 zeros, we can give a one address. Likewise, we can change the combination until 4 ones are given, right? So here, I'm going to show you 4 addresses of the first page. So this will be address like 0000. This will be address like 0001. This can be addressed as 0010. And this can be addressed as 001 and 1. Right? So those are the first 4 numbers of this thing, right? So this represents 2, and this represents 3, right? So that means 1, 2, 0, 1, 2, 3 is given to these 4 bytes. Right, people, are you okay until this point?
අන්තිමට කරපු calculation එක ආයෙත් check කරන්න.
ඒ කියන්නේ මේ නිර්මාණ බිංදුව 1 2 3 ආප එකද?
ඔව් සර් ඒක.
ඒක නිර්මාණ මෙතනින් තමයි පාවිච්චි කරගන්නේ. ඒ කියන්නේ දැන් 8 4 2 1 කෙලින් තියෙන බිංදු සහ 1 වයින් තමයි ඒක ඩිෆයින් වෙන්නේ. 4 දෙනාටම බිංදුව වැටෙනවම බිංදුව හැදෙනවා. එක තියෙන තැනට පහලින් එක වැටලා අනිත් තුන් දෙනාට බිංදු දැම්මම එක වැටෙනවා. දෙක තියෙන
සර් අට බයිනරි වලින් හදාගත්ත විදිහටමද ගන්න එතන.
ඔව් මේ බයිනරි වලින් හදාගත්ත විදිහම තමයි මේ ක්‍රමෙන් ගන්න එක අපිට ලේසි. 1 2 4 8 දාගෙන ගන්න එකෙන් ලේසි. නැත්නම් ඉතින් ඔයාට අර 1 2කින් බෙදලා 2 2කින් බෙදලා එහෙම ගන්න ඕනේ.
නෑ සර් මේක ලේසි නේද කිලින්ම.
ඔව් බිට් 4ක් එන එකෙන් ගන්න එක ලේසි.
හරි සර්.
Right? Okay, so likewise, all 16 bits will have 16 different addresses, right? So now, when these bytes are being inside the logical memory, the next destination is the physical memory, right? Then api hard disk එකේ program එක double click කරාම processors හැදුනා. ඒ process එක එයාගොල්ලන්ට අදාළ logical memory එකට දාගත්තා. Then these logical memory එකේ තියෙන මේ data, we got bytes inside it. These bytes need to be put inside the physical memory, RAM එකට දාන්න ඕනේ. Now I told you this process will not be done at the will of operating system, right? Operating system එකට උවමනාම විදිහට නෙවෙයි මේක කරන්නේ, මම manage කරනවා, but ඔහේ දාන්නම් වාලේ දාන්න බෑ. So for that, memory management unit will be involved. So memory management unit is having a table called page table, right? Even though it is called page table, it has 3 important columns. Page table එකේ තව columns තියෙනවා. Like there are 3 important columns in the page table, right? So if I draw the page table like this, let me refer the diagram. කොච්චර ඉඩ යනවද කියලා ඔළුවට අරගන්න ඕනේ. Okay. Yeah, it's better we go with a little bit further. Yeah, let's go like this. Right, I'm not straight away taking this particular diagram to you. It will be a little bit complex. That is why I'm drawing this, right? Okay, now what is going on is like this needs to be moved to the physical memory. So to do that, I need the page table. So I'm taking my page table over here. Page table has three important columns. One is page number. The other one is frame number. I'll tell you what is a frame is. The other one is the status. Yeah, present absent status. Right? So page numbers will be the page numbers that is referring our particular pages. May pages tika refer karana, may pages වලට අදාළ page numbers tika තියෙනවා. Right? So it will be what? There are 4 pages, which means 0. I'll take another color. 0, 1, 2, and 3. Right? And frame numbers, now when it comes to the frame numbers are referring from the physical memory, right? Not from the logical memory. Logical memory has pages. Physical memory has frames. Now let's look at how the physical memory works. Now, usually inside a computer, a physical memory and a logical memory can stay in 3 different ways. Sometimes logical memory is bigger than the physical memory. Sometimes they are equal in size. Sometimes physical memory is bigger than the logical memory. However, it doesn't matter who is the bigger one. Inside the physical memory, it has a component called frame. Right? In the logical memory, we had something called page. Now this has a component called frame. Right? So this is called as we name the pages, this can be named as frame 0, frame 1, frame 2, likewise until frame 8, frame 7, right?
So අපි frames ඔතන ගත්තේ 3යි නේද ඔක්කොම?
මට තේරුණේ නැහැ.
ඒ කියන්නේ ආරගේ කලින් ගිය අපි ගත්තේ. sorry pages 3ක් නේද ගත්තේ?
pages 4ක් තිබුණේ. 0 වලින් පටන් ගත්තේ.
ඒ frames අපිට කියන හිතන ගානක් නේද සදාන්නේ?
ඔව් මෙතන මම මේක දාන්නේ මම කියන්නේ මම determine කරගත්ත ගානක්. right? ඔය මේ ටික connect වෙන විදිහ අන්තිමට අපි equations ටික කතා කරනකොට ඔයගලන්ට figure out වෙනවා. දැනට මේක මේ විදිහට okay කරගන්න 0 1 2 3 4 5 6 7 yeah එක frame එකක් වැඩි ප්‍රමාණයකට තියෙනවා. leave on this. Right. So the important part is if a particular system has a page on some size, then page එකේ size එක 4 byte කියලා අපි කතා කරගත්තානේ නේද? මේක තිබුණේ 4 bytes. So if a particular system is having a page in a logical memory, the same size will be there in the physical memory when we are considering a frame. Page එකේ frame එකේ size දෙක ඕනම system එකක එක size, right? So this can be considered as 4 bytes again, right? So again, these 4 divided into 4 parts. Right? So again, as we see it in the logical memory, this is a capacity of 1 byte. Right? So if I make this smaller, this is the picture show so far. Right? So logical memory has pages, physical memory has frames, right? Logical memory get pages from the when they are trying to execute a process. So this particular logical memory's content will be given to a particular physical memory content. Now the problem is how this content can be given. Then logical memory එක ගත්තොත් logical memory එකේ මෙහෙම bits 16ක් bytes 16ක් තියෙනවා. Address කරලා තියෙන bytes 16ක් තියෙනවා. So inside the physical memory there are space to put things inside, right? හරියටම logical memory එකේ bit එකක් ගෙනල්ලා physical memory එකේ bit එකකට දාන්න පුළුවන්. It's the same size. ඒක ඇත්තටම වෙන්නේ page එක පිටින් ගෙනල්ලා දාන එක. එක page එකක් ගලවලා ඉල එක frame එකකට දාන්න. Right? So a page එක මොන frame එකකටද වැටෙන්නේ? 0th page එක is coming to the which frame? First page is coming to the which frame will be determined by the page table. Right? That is why I told you operating system is not having the control, or like when the pages will be placed inside the RAM in the physical memory, operating system will not have the freedom to put it as it is. Page table එකේ කියලා තියෙන විදිහට තමයි ඒක දාන්න ඕනේ. Page table එක කොහෙද තියෙනවා කියලා මම කිව්වේ? This page table is inside the MMU. Right? Memory management unit. Right? Okay. Now how this happens? Now inside the page table, there is a specific allocation for the specific pages. Right? Yeah, let me refer the diagram. What are the numbers that I have taken? Yeah, 7413. All right, it's good. Yeah. So here, as the frame numbers, I have taken this as 7, 4, 1, and 3. So that means 0th page is going to be allocated inside the 7th frame. First page is going to be allocated in the 4th frame. Second page is going to be allocated in the first frame. And third frame is going to be allocated in the third frame. Right? Then මෙතන frames ටික ඔයගලන්ට පේන්න තියෙනවා. Right? Now you know which page is going to be allocated to which frame. And this page table is needed to identify which particular address is going to be set inside the physical memory on which particular physical address. Mea logical memory එකේ තියෙන නිසා මෙයාට අපි කියනවා logical address එක කියලා. It's the logical address. Right? So to place this bit, which refers by this logical address inside the physical memory, it needs to be converted into a physical address. Like we see in the logical memory, each and every byte has an address. Inside the physical memory, they do have an address for their self as well. Now the problem is number of squares inside this. දැන් මේකේ තියෙන පුංචි කොටු ටික ගණන් කරොත් එක කොටුවක හතරක් තියෙනවා, හතර ගානේ කොටු 8ක් තියෙනවා. That means 32 bytes are here. Bytes 32කට ඉඩ තියෙනවා මෙතන. Right? So here it is only 16 bytes. So to address 32 bytes uniquely, we need 5 bits. Bits පහක් ඕනේ. Right? Let me illustrate it to you. So I should need this much of things. So these will be considered as 1, 2, 4, 8, and 16. Right? So I need this much of bytes, I'm sorry, this much of bits, ones and zeros, to address all these 32 bits. Right? So the smallest value that I can take is 5 zeros. Right? So if I want to represent 1, so I'm going to take 4 zeros and 1. That's going to be 1. If I want to represent 2, it's 3 zeros, 1 and a 0. If I need to represent 3, it's 3 zeros, 1, 1. Right? So likewise, to represent 31, I need all my 5 places to be filled with 1. So 0 to 31 වෙනකන් numbers පෙන්වන්න පුළුවන් when we have in 5 bytes or 5 places. Right? So because of that, each and every byte will be named with 5 different bytes. Right? So if I take this will be represent as 0, 0, 0, 0, and 0. It's better I end the divisions. Right? So this frame likewise, and this frame like this, and this frame right? So it can be named like that. When it comes to the physical memory, since number of bytes are big, so address is getting bigger. Right? Now what's happened when a particular address is being converted into a particular physical address? Right? So it happens like this. Now this is what we call mapping. දැන් මෙච්චර වෙලා ආපු එකක් මම චුට්ටක් ආයි finalize කරන්නම්. I may name this as the physical address and this is as the physical memory. Hold on. Right now this is called the physical memory. this can be named as physical address. Right? So how this mapping is going to happen? Mapping කියලා කියන්නේ මේ one particular byte එකක් logical memory එකේ තියෙන මොන frame එකේ ගිහිලාද fix වෙන්නේ. එයාට එතකොට හම්බෙන address එක මොකක්ද? Right? So for that I'm going to consider this particular bit, right? මෙයාව තමයි මම consider කරන්නේ. Right? So this particular logical address, there are two parts regarding a logical address. මේ අපි ලියන sequence එක කොටස් දෙකකට කැඩෙනවා. මේකට අදාළව කැඩෙන්නේ මෙන්න මෙතනින්. bits දෙක ඒක දෙක කැඩෙන්නේ කොහොමද කියන එක ඔයගලන්ට equations ටික කතා කරනකොට figure out වෙයි. Right? So the first part is called the page number. Right? And the second part is called the offset. And this page number, sometimes they call it page address. Offset, they sometimes call it as displacement. Right? So when we are referring to the page table, or like when the operating system is referring to the page table to find out what is the corresponding frame number. The physical memory එකේ frame number එක හොයාගන්න මේ page table එකට connect වෙලා. Now in the physical address, it also been divided into two parts. One is called the frame number and the other one is called the offset. It's not going to change. Right? So this is called the frame number. Or the frame address, sometimes they say. And this is offset. Take a change in there. Right? Okay, let's see what's happened so far. So when it comes to the computer system, the computer has its program in the hard disk. So once we execute a hard disk, we can have, it will create processors, right? So those processors will have a logical memory and contains the addresses for each and every byte of that particular process. And what we are trying to do, what the operating system trying to do is taking all the bits from the logical memory and trying to place it in the physical memory, that is the RAM. And the RAM is having frames which is the same size as the page, and each and every bit, each and every byte inside the logical memory as well as the physical memory has their own address to identify them uniquely, right? So since we got 16 bytes or 4 pages here in the logical memory, we use 4 bits to address those 16 pages uniquely. Since we have 32 bytes inside the physical memory, we use 5 bits to address them uniquely. Right? එතකොට bit 4කින් අපිට address 16ක් පෙන්වන්න පුළුවන්. bit 5කින්, ඒ කියන්නේ ones and zeros 5කින් අපිට address 32ක් පෙන්වන්න පුළුවන්. ඒක නිසා තමයි අපි logical memory එකට bits 4කුයි physical memory එකට bits 5කුයි තියෙන address එකක් අරගන්නේ. Now the problem is, like, if you consider one particular byte in the logical memory, to which place, to which address in the physical memory that it is going to be assigned. Logical memory එකේ තියෙන byte එකක් physical memory එකේ කොතනටද access කරන්න. Right? So to resolve this, operating system use the page table which is given by the memory management unit. Right? So here what they are doing is something very simple. This address, this 0011, now I'm going to refer to this address. Right? මම එයාගේ border එක කොළ පාටින් අඳින්නම්. So you can recognize that easily. So from the address of a particular byte, they refer the page number of that address. Now, what is the page number of this address? It is the first portion, which is 00. Right? So that 00 will be referred from the page number. So this has 0011, I guess. Yes. Right? So what's happening here is it will refer this particular address from the page number. Why I'm pointing it to 0? Because 0 can be written as 00 in binary. 1 can be written 01 in binary. 2 can be written 10, and 3 can be written as 11. Right? Now, if you look into the page numbers, all page numbers are in 2 bits. Bit දෙකකින් තමයි page number එක represent කරලා තියෙන්නේ. So that is why I have written 2 bits variation to the 0, 1, 2, and 3. ඊට පස්සේ frame එක ගත්තොත් frame එකේ නේද මම කියවනේ ඉස්සරහා කොටස තමයි frame number කියන්නේ කියලා. frame number එකට 3 bits පාවිච්චි කරලා තියෙනවා. So here I am writing this frame number in 3 bits. Right? So 7 means 111. 4 means 100. 1 means 001. 3 means 011. Right? So now what they are doing is when the mapping is happening, this page number part, logical address එකේ තියෙන page number කොටස එයා ගලවලා ගන්නවා අරගෙන එතනට fix කරනවා frame number part එක. Right? So the simple thing that it's doing, from the logical address, get rid of the frame number, page number part, and replace that, or like fix the frame number part instead of the page number. Right? So this 00 frame is going to refer 00 page is going to refer the 7th frame, which is 111. So the 7th frame is where? Here's the 7th frame. This is the 7th frame. Right? So that means this particular byte, මේ කොළ පාටෙන් මම අඳුරු කරලා තියෙන මේ පුංචි byte එක is going to place somewhere inside this frame. 7th frame එක ඇතුළට තමයි යන්න ඉන්නේ. Right? The 7th frame එකේ තියෙන numbers ටික ගැන අපි හිතුවොත් it's going to be 111 කියලා මේ 10000111 කියන patterns ටිකත් එක්ක යා match කර ගන්නවා. Right? මම ඒක ලියන්නම්. ලිව්වම ඔයගලන්ට මේ දෙකේ තියෙන සම්බන්ධය පොඩ්ඩක් තේරෙයි. This has 11101. Right? I'll start it with 00. Right? And this is going to have 11101. And this is going to have 11110.
So එතකොට 7 හදලා මේ අර frame number එක නේද 10 ගන්නේ. 0 එකයි 1 එක 2 එකයි
ඔව්
3
හොඳ පෙන්නන්න
ඒ ටික නේද සර්?
නිර්මාණ ඔව් ඉන්න
හරි
11111. මේකේ වෙලා තියෙන්නේ මොකද්ද? මෙන්න මෙතනින් අපේ frame number එක change වෙන්නේ. Right? So let's see what happens. දැන් මේ physical memory එකේ represent වෙලා තියෙන විදිහ බලන්න. මේ frame number එක මේ තැන්වලදී හැමතැනම 000. මෙයාගේ frame number එක හැමතැනම 111. Right? ඊළඟට බලන්න data එක offset එක change වෙලා තියෙන විදිහ. මේ 00011011. So same goes here. 00011011. Right? There is a pattern always. Right? දැන් මේක තේරුම් ගන්නකොට ඕක හරියට මෙන්නේ කොහොමද කියන එක නෙවෙයි මේ කතාව තමයි පැහැදිලි කරගන්න ඕනේ. Right? So if I consider this particular address, මේ 0011 කියන address එක ගැන මම හිතුවොත් එයාව map වෙන්නේ මෙහෙමයි. මෙයාගේ තියෙන්නේ 0011 the logical address. Right? So this is logical address. And it's going to convert into the physical address. How? Page number part will be replaced by the frame number part. Offset is not going to change. Right? Let me put the offset in a different color. Offset කියලා ඉන්න 11, it's going to be same in the physical address. right? But for 00, the page number 00, what is the frame number that you are going to add? It's going to be 111. So this is the frame number and the offset, right? එතකොට මේ මෙතන අපි කතා කරේ ඒකයි 00 කියන frame number page number එකට 111 කියන frame number එක තමයි fix වෙන්නේ, right? So this big logical address will be converted into the physical address like this. Okay. So that means this frame is going to be refer what? It is going to refer this particular frame in the physical memory. Which particular frame? This particular frame. Right? So this is what we call mapping, right? Logical to physical address mapping. Okay, let me recap what has happened. Right? And the පොඩක් ආයෙ මුලින් ඉඳලා කියන්නම් මම සිංහලෙන් කියාගෙන යන්නම් පොඩ්ඩක් කතාව විස්තර වෙච්ච නිසා, right? So we got hard disk. අපේ hard disk එකේ තමයි programs ටික install කරලා තියෙන්නේ. Once we execute a particular program, ඒකට අදාළව there will be processors හැදෙනවා. So this process we consider it as 16 byte. So each and every process there is a logical memory. Logical memory එක තියෙනවා හැම process එකකටම අදාළව. අපි ගත්තේ P3 process එකේ logical memory එක. So එයාගේ 16 bytes පෙන්වන්න මේ logical memory එකේ 16 bytes allocate වෙලා තියෙනවා. pages 4ක් තියෙනවා. logical memory එක හැදිලා තියෙන්නේ pages වලින්. page එකක් ඇතුලේ specific bytes ගානක් තියෙනවා. right? එතකොට එක byte එකකට unique address එක ගානේ තියෙනවා. එතකොට මෙතන byte 16ට unique address 16ක්. එකිනෙකට වෙනස් addresses 16ක් එන්න ඕනේ. එතකොට binary වලින් addresses 16ක් එන්න අපි දැන් කතා කරගෙනනකොට කොහොමද රටා 16ක් එන්නේ කියන එක. right? එතකොට ඒ වගේ addresses 16ක් තියෙනවා. Then the need is mapping the logical address into its corresponding physical address. Logical address එකට අදාළ physical address එකට match කරගන්න එක තමයි උවමනාව. එහෙම නැතුව මේ physical address එක ඇතුළට logical address එකේ තියෙන data එක දාන්න බෑ. Right? So for that they get use of this page table. Page table එකේ තමයි තියෙන්නේ specific page number එකක්. එයාට corresponding frame number එක මොකක්ද කියන එක අඳුන ගන්න. right? එතකොට වෙන්නේ page table එක අනුව බලලා page number එකට අදාළ වෙන frame number එක fix කරගන්නවා. right? ඒ fix කරගෙන physical address එක හදා ගන්නවා. physical address එක හදාගත්තම RAM එකේ කොතනටද ගිහිල්ලා fix වෙන්න ඕනේ කියන එක address එකෙන් manage කරනවා. එතකොට අර කොළ පාටෙන් පාට කරපු byte එක මෙන්න මෙතනට තමයි ඇවිල්ලා fix වෙන්නේ. right? එතකොට මේ කොළ පාට byte එක කලින් හිටියේ logical memory එකේ මෙන්න මෙතන. okay. people, is this clear? කතා බහ පැහැදිලිද?
So එතකොට logical address එකේ තිබ්බ මේ logical එකේ තිබ්බ මේ බින්දු දෙකන සර් තිබ්බේ කියන ඔෆ්සෙට් එක නේ මං කියන්නේ.
ඔව් ඔව්.
ඒ කියන්නේ page එක තිබ්බේ logically බින්දු දෙකයි කියලා සර්.
ඔව්.
ඒකට frame number කියලා ගද්දි මේ එකේ තුනක් ආවේ කොහොමද?
ඒක තමයි නිර්මාණ මෙතනින් හදාගන්නේ. ඒ කියන්නේ වගේ ෆිසිකල් එකකින් ලොජිකල් එකට එනකොට ඇඩ්‍රස් එකේ තියෙන සයිස් එක චේන්ජ් වෙන්න පුළුවන්.
හරි.
right. එතකොට page එකේ බිංදු දෙක ගලවලා frame එකේ එකේව තුනක් fix කරා. එතකොට කලින් logical address එකේ තිබුණේ bit 4යි. address එකේ දිග bit 4යි. physical එකේ address එකේ දිග bit 5යි. ඒක සිද්ධ වෙන්න පුළුවන්.
හරි.
right. ඕක අර විදි තුනටම වෙන්න පුළුවන්. ඒ කියන්නේ logical address එකට වඩා කොට physical address එකක් හැදෙන්න පුළුවන්. එතකොට logical address එක logical memory එක ලොකුයි physical memory එක පොඩි. සමහර වෙලාවට දෙන්නම එකම size වෙන්න පුළුවන්. එතකොට physical memory එකයි logical memory එකයි දෙකම size එකෙන් සමානයි. එතකොට කොටු ගාන සමානයිනේ. කොටු ගාන සමාන වුණාම සමාන bits ගානක් ඕන වෙන්නේ address ටික අරගන්න. සමහර වෙලාවට මේ අපි අරගත්ත සිටුේෂන් එක වෙන්න පුළුවන්. logical address එකට වඩා physical address එක ලොකුයි. right. okay මං හිතනවා ඕක clear කියලා. right. clear නැත්නම් ආයි කියන්න මං එතකොට ආයි සරයක් explain කරන්නම්. දැන් මේ present absent status එක ගැන කියන්න ඕනේ. right. දැන් මම මේ මෙච්චර වෙලා කතා කරේ එක fix විදිහක් අරගෙන. fix විදිහ කියන්නේ මොකක්ද? page number එකට corresponding frame number එකක් තියෙනවා. අන්නේ frame number එකට against තමයි mapping කියන එක සිද්ධ වෙන්නේ කියන එක. but practically ගත්තම ඕක ඇත්තටම control වෙන්නේ මේ present absent කියන status එකේ. right. එතකොට මේ present absent status එකෙන් කියන්නේ specific frame එකක් පාවිච්චි කරන්න පුළුවන්ද බැරිද කියන එක. right. Hold on a second people. I need to confirm about the present absent thing, whether it is can be used or cannot be used. Right. Hold on. Entry if this bit is yeah. 1 second, I have to reconfirm. Right. So now this present absent bit, it can indicate two status, which is 1 and a 0. Right. 1 තියන්න පුළුවන්, 0 තියන්න පුළුවන්. 1 is indicated, I'll make this as 0. Right. I'll make this as 1. Let me make all other places as 1. So 1 is indicating the corresponding frame is in use. එක කියලා indicate වෙන තැනට වම් අත පැත්තෙන් තියෙන frame එක use වෙනවා මේ වෙලාවේ. ඒ කියන්නේ data තියෙනවා කියන එක තමයි ඒ කියන්නේ. 0 කියලා තියෙනවා නම් that indicates I am free, someone can use me. Right? So it's better we mention about that. So 0 indicates corresponding frame is free to use. 1 indicate corresponding frame is occupied, right? Then memory management වලදී ඇත්තටම සිද්ධ වෙන්නේ 0 කියලා bit එක වැටෙන තැන present absent bit එක 0 කියලා indicate වෙච්ච තැනක් මේ ඕනම page එකකට පාවිච්චි කරන්න පුළුවන්. දැන් අපි මෙතනදී කතා වුණේ 0ත් එක්කෙනා හරියටම මෙයාව පාවිච්චි කරනවා කියලා. එහෙම නැතුව මේ වෙන කොහේ හරි හිතන්නකෝ මෙතන bit එකක් 0 වුණා කියලා. එහෙම වුණා නම් 0ට මේ frame එකක් පාවිච්චි කරන්න පුළුවන්. එතකොට එයා map වෙන්නේ 0 0 කියන කෙනා map වෙන්නේ 0 1 1 කියන කෙනත් එක්ක. ඒක තමයි practicallyම සිද්ධ වෙන ක්‍රියාවලිය. අපි අර අපේ mapping එක හරියට කතා බහ කරගන්න අපි corresponding කියලා අරගන්නවා, right? But it's better you remember what actually happens. Present absent bit එක තමයි මොන frame එකද ඒ moment එකේ available කියන එක indicate කරන්නේ. එතකොට 0 තියෙනවා නම් that means that frame can be used. 1 කියලා තියෙනවා නම් that means that frame cannot be used. Someone is in that particular frame. Then එහෙම වුණාම දැන් මේ page table එකේ හැටියට page 1 2 3 have to wait until this frame 413 is being freed. මේ වෙනකොට වෙන කවුරු හරි program එකක් ඒක පාවිච්චි කරනවා. right? ඒකයි මම කිව්වේ RAM එකේ there can be lot of processes. මේ අපි කතා කරන්නේ එක process එකක් ගැන විතරයි. ඒතර ඒ process එකේ 0th page එක විතරයි RAM එකට යවා ගන්න පුළුවන් වෙන්නේ. ඉතිරි pages තුන RAM එකට යවන්න විදිහක් නැහැ. ඒගොල්ලන්ව map කරන්න ඉන්න frame ටික මේ වෙලාවේ තව එක්කෙනෙක් පාවිච්චි කරනවා. right? So එතන මෙයාගේ status එක 0 කරගන්න ඕනේ for the corresponding page to be go inside the frame.
0 එක නේද free තියෙන්නේ?
ඔව් 0 කියන්නේ free කියන එක. ඒතර 0 කියන්නේ මේ 111 කියන frame එක free. 7th frame එක free. data දාගන්න පුළුවන්. 1 කියලා තියෙනවා කියන්නේ not free. යා already filled. කාගෙන් හරි පිළිලා. මේ program මේ process එකේ නෙවෙයි වෙන process එකක දේවල් වලින් පිරලා තියෙන්නේ. ඒතර ඒ process එකේ දේවල් ටික එතනින් අස් කරාම තමයි මේ process එකේ තියෙන දේවල් වලට එතන පිරෙන්න පුළුවන් වෙන්නේ. Okay, people. So it's time for you to draw now. Right? So I'm going to shrink the hold on. Yeah, I'm going to zoom out the screen and you may zoom in and start drawing the diagram. Right? And meanwhile, if you got any problem regarding this, you can ask. Right, by next week the මේක මේ කියලා දුන්නේ concept එක ඔළුවට යන්න. ගණන් ටික ඊට වැඩිය ගොඩක් ලේසි. ඊළඟ සතියේ ගණන් ටිකයි equations ටික මුලින් කතා කරලා ගණන් හදන පැත්තට යනවා. right? එතකොට ඔයගලන්ට තේරෙයි ඒක කරගන්න එක කොච්චර ලේසිද කියන එක. right? It's better you try to understand what's going on here.
So ගණන් ටිකේ තියෙන අර bit byte ඒ calculation ටික
right.
නේද?
Yes, calculation එක තියෙන. Yes, yes. තමයි මෙන්න මේ රතු පාට ඉර ඇඳ ගන්න එපා. ඒක ඔයගලම පොඩ්ඩක් මිස්ලීඩ් කරනවා. මෙන්න මෙයාව. එතන අපි corresponding day විතරක් ලියාගමු. අකිල පුතේ ඩයග්‍රම් එක ඇඳ ගන්න වෙන්නේ ඔය විදිහටම තමයි. ඔයාට නෝට් එක මම එවන්නම් පුතේ සිංහල මීඩියම් එක. නැත්නම් වීඩියෝ එකද ඔයාට ඕනේ? රයිට් මම ඔයාට මේ වීඩියෝ ලිස්ට් එක බලලා කියන්නම් කොතනද බලන්න ඕනේ කියලා.
සා present absent status එක හොයාගත්තේ කොතනින්ද? ඒ කියන්නේ frame number එක දිහා බලලාද logic sorry page number
ඒක
දිහා බලලාද?
ඒක නිර්මාණ present absent status එක තීරණය වෙන්නේ අතරම operating system එකකින්. මම ඔය ඒක එහෙම තීරණය වෙලා තියෙන එක අවස්ථාවක් ගැන කියපු එක තමයි කරේ.
ඒතකොට අපිට හිතන්නේ නැති විභාගෙට status
නෑ.
එක.
ඒ present absent status එක ඔයාලට දෙනවා විභාගෙ.
හරි.
right? Let me know when you are done, people. If you are done with drawing, people, you can disconnect. So I'm going to end the session by this thing. So I will stay until all of you are leaving. Just complete the diagram clearly, people. Okay, Netmi, thank you. Right, so you can leave, no problem, Dua.
මේ මෙතන ෆිසිකල් මෙමරි කියන ටේබල් එකේ මේ zeros අරගෙන අපේ ලොජිකල් සෝරි ෆිසිකල් ඇඩ්‍රස් එකේ
ඔව්
zeros තුනක්නේ දාලා තියෙන්නේ
ඔව්
අපේ ෆිසිකල් මෙමරි ටේබල් එකේ
ඔව් ඔව්
zeros තුන කියන්නේ එතන අගයක් නෑ නේද මොකක්වත්
නෑ එහෙම අගයක් නෑ කියලා අරගන්න බෑ නිර්මාණ ඒ zeros තුන තියෙනවා ඒකෙන් ෆ්‍රේම් නම්බර් එක 0 කියන එක තමයි ඉන්ඩිකේට් වෙන්නේ right ඒ කියන්නේ zeros තුන තිබ්බ කියලා එතන අගයක් නෑ කියලා අපිට කියන්න බෑ එයා ඩිෆරන්ට් ඇඩ්‍රස් එකක් ඉන්ඩිකේට් කරන එක පැටර්න් එකක් තේරුණාද
zeros තුනටත් වැලියු එකක් තියෙනවා කියන එකද කියන්නේ
ඔව් zeros තුනට වැලියු එක තියෙන්නේ 0 right ඒ කියන්නේ මේ logic දැන් මේ logical memory කියන්නේ address එක memory address එක පෙන්නන්නේ ones and zeros වලින් ඒක ඇන්තල පෙන්නන්නේ ones and zeros වලින් එතකොට අපිට මේ කියන්නේ zeros තුන තිබ්බ කියලා ඒ ඉස්සරහා තියෙන zeros තුන නැතුව 10 විතරක් 01 විතරක් තියන්න බෑ bit පහම ඇඳලා පෙන්නන්න ඕනේ නිර්මාණ
හරි
right
සර් තව වෙනින් පාඩමක ප්‍රශ්නයක් තියෙනවා දැන් එහෙමකට කමක් නැද්ද
හරි තප්පරයක් ඉන්න මම රෙකෝඩින් එක ඕෆ් කරලා එන්නම්